Okay, so that covered adding radicals. Now let's turn our attention to then the other thing we've been working on is reviewing solving equations. Now, as we're looking at here today, we got some fractional equations, and you probably, if you're working around with me right now, you definitely want to have your calculator out because I know some of these numbers might get kind of large. And then we got some proportions as well to solve. So let's go through here and let's talk about number 15, okay? Clearing out fractions. If you don't like fractions, then get rid of them. We get rid of them by not turning into decimals, but finding some type of common number, some type of constant that we can multiply this entire equation by. That's going to clear out the fractions. And the first thing I want to do is first take a look at that equation as a whole and make sure they are all mixed numbers. I don't want any, sorry, not mixed numbers. I want all improper fractions or proper fractions. And what I notice is 3.5x. 3.5x is a mixed number, so let's change that to an improper fraction. 3 times 2 is 6. 6 plus 1 is 7. So the equation I want to actually deal with, everything else looks cool, is negative 3 halves x plus 7 thirds, negative 31 6, and minus 7 halves. So mixed numbers change them into impropers. And now we're going to multiply this entire equation by what number? What number is going to clear out these fractions for us? So I look at the denominators. The denominators I see are 2, 3, and 6, and another 2. So what number can 2, 3, and 6 all divide into nicely? That's going to be the number that we're going to multiply this through by. So I always have kids say 2, but can 2 divide into 3 nicely? No. What I'm looking for is 6. 6 can be multiplied through by everything, and 2 can go into 3, sorry, not 3. 2 can go into 6, 3 can go into 6, and 6 can go into 6. So I will multiply this entire equation, everything, by 6. So let's do that. I'm going to take negative 3 halves x times it by 6. I'm going to take 7 thirds times it by 6. I'm going to take everything, both sides of the equation, and multiply by 6. Now it's using your fraction skills going back to 3rd grade, 4th grade, 5th grade, whenever you started multiplying fractions. 3 halves, negative 3 halves times 6. You can multiply the numerators together, then the denominators, and then reduce. I usually like to reduce first and then multiply what's left over. By doing that, you don't necessarily need a calculator. The number is a little bit smaller to work with, but there will be some times where the numbers just do get large. So what I mean by that is I'm reducing first. 6 divided by 2. 6 divided by 2 is, I'm going to kind of change a different yellow, probably not, is 3. And what's 3 times negative 3? Negative 9x. And then 6 divided by 3 is 2. 7 times 2 is 14. 6 divided by 6 is 1. And what's 1 times negative 31? 6 divided by 2 is what? 3. And negative 7 times 3 is negative 21x. Silly mistakes that happen is you forget to bring down an x. You can't read your own handwriting. Or you accidentally multiply when you should have, you accidentally added when you should have multiplied. So your goal here is to clear out the fractions, and what we've done now is given ourselves a nice integer equation that we've all been solving for a few years. Got x's on both sides. I'm going to add over 21x now. Negative 9. Negative 9 plus a 21 is 12x. X is all on the left. I'm moving everything else to the right. Watch your signs. Negative 31. I'm running out of room here. Negative 31 minus 14 is negative 45. Divide by 12. Okay, a lot of times on these questions, they don't always turn out to be nice integer answers. That's fine. Leave it as a fraction, but always reduce it. An improper fraction is just fine. What can 45 over 12 reduce by? 3. Negative 15 over 4 and there's my solution, okay?